So let's go into chemistry, separation techniques. So alright, yeah, we're looking at how we separate, mixtures. And yeah, we know the very first thing we need to understand is our mixture. And what is a mixture? Mixture contains two or more constituents that can be separated by physical method. So that physical method that we use in separating a mixture is what is called your separation techniques. Are you with me? Your separation techniques. So alright, now I said mixture contains two or more different substances. A perfect example of a mixture is your palm wine. Are you with me? Your palm wine. And in your palm wine, you'd actually have, how do we know that palm wine is a mixture? We know that it's a mixture because you say that palm wine is alcoholic, it contains alcanol. We see that palm wine is sweet, so definitely it's having sugar. And we say that it's actually rich in some classes of food, in which it will definitely be rich in your vitamin, your minerals, that's mineral salts, then you'd have fats, then you have, the thing is liquid, then you have water. So, and the likes. I think there's two classes of food that should be there, which is it must have a protein, then what would make it ferment? Let's add our yeast. So as you can see, all these things are what palm wine is made up of. So you can see alcanol, sugar, vitamin, and everything. So these are what this palm wine is contains. Alright, so these are the constituents of this particular mixture. So I'm able to prove that palm wine is a mixture. Now, if we are actually now going to separate this constituent, we'll now go and apply this separation techniques. Are you with me? So it's separation techniques that would help us, separate this our constituents, and that's what we'll be looking at today. Now, in here we'll be taking their individual physical properties. That's what we would use to know which one we should separate from which one. Are you with me? Now, because mixtures would actually, the constituent of a mixture would actually retain their individual properties. So each constituent of a mixture would actually retain its individual properties. So we would now take the advantage of these physical properties. We will now use it to let me separate this one from this one. Okay, this one dissolves in water. Why this one do not dissolve in water? So why not me use my simple distillation to obtain this soluble solid from the solution, so that I can now get my salt. Do you get what I'm saying? Now, when we get to various types of separation techniques, I would explain very well with examples. So that's separation techniques. Very easy. So alright, now we see that since each constituent of a mixture would actually retain its properties, its individual properties. For example, you know that in this 1, 2, 3, 4, 5, 6, 7, 8 actually mixes together, bringing us to a mixture here. So and we see that normal, if this thing should mix, at least it's supposed to the properties is supposed to mix together. But no, that's not the case under mixture. That's not the case. The properties would not mix together. The properties would still be different in that same mixture. The property will still be different in that same mixture. Meaning that my alcanol, are you with me? My alcanol would have its properties there. Sugar too would have its properties and the likes. So we will now take the advantage of these properties. We will now use it to what? To now like to now separate mixtures. That's why we now have various types of separation techniques. We have the one of sieving. Let's talk about the types now. We have the one of sieving. We have that of decantation. Let's take it one after the other. Magnetic separation. We have the one of decantation. We have the one of decantation, filtration. We have the one of flotation, flotation. We have the one of centrifugation. Are you with me? Centrifugation. Follow closely, please. You'll be needing all these things. I'll be explaining in such a way that you will not forget again. Alright, so we have our evaporation. Then you'd have your distillation, crystallization. This is fractional crystallization. So B is fractional crystallization. Then you have you have your separating funnel method. Then you have chromatography, fractional distillation. Then you have chroma. Are you with me? Chromatography. I hope that's all. Chromatography. So alright, let's now take them one after the other. Let's add this place. There should be precipitation here. So let's take them one after the other. So let's take this sieving. So the video is actually going to be a very short one, so just explain these techniques and then we call it a session already. Are you with me? So sieving is like telling you that when you have like solid of different sizes, alright, this is your, like, let's assume this is our bowl containing our yam flour. Should we use yam flour? Yeah, because you can use your yam flour now. Let's use our yam or cassava flour. Let me just write flour in there. Or maybe because it's actually used widely in Africa, it's employed in this gari production stuff. So yeah. Now, so like this sieving is just like you having, a mesh, like how would I call it now? A material that can actually separate solid of different sizes. Okay, you have solid that have this kind of size in a bowl. Then you now have another one that is kind of tiny, mixing together with all these big one. So how are we actually going to separate it? As you can see, this is solid 1, this is solid 2, forming a mixture. We will take note of their individual properties. You can see that one is actually bigger in size while one is smaller. What do? You sieve. You can carry your sieve. Your sieve will actually have a mesh, so you carry it. Let's just take an example that this is the sieve. So something like a net will be on it. Now you now pour this thing. You pour it inside this mesh. You see that the one with bigger particles would actually come down. Are you with me? The one with the powdered particles, or let's say the one that is actually small in size, would pass through the mesh. You get pass through the mesh. Let's employ it here. Something like this. Let's just assume that this is your mesh. So having a net, we call it a mesh. So now you now pour this 1 and 2. When you pour it into this place, So maybe you put the mesh on another bowl. Maybe you put it on another bowl like this. So what will happen is that when you pour this here, the one with bigger particles will now stay on this mesh. Then the one with smaller particles will now come inside. So you're actually separating the big solid from the so separating solid of different sizes, you would employ this one. Let's go to this one. Magnetic separation. All right, magnetic separation is just the method you use to like separate magnetic substances from non-magnetic substances. So if you have a magnet that is having your north pole and south pole, then another material that is not even having any pole, what will happen? You separate. Magnetic separation will separate it. So magnetic separation from what? Non-magnetic separation. Shey you get? Magnetic solid from non-magnetic solid. Now sublimation. We did not even add it. Let me smuggle it in. Let me smuggle it in here. So there is no how you talk about separation techniques and you will not talk about sublimation. Are you with me? Sublimation, you see, when some solid are actually heated, they will pass through the gaseous state without going passing through without passing through the liquid state. They will just go directly into gaseous state, and it's employed. This one is actually employed in some sort like your ammonium chloride, and as well as iodine. Are you with me? Iodine. Alright, so these substances can be separated from other solid by sublimation. So if you have other solid with this, you can actually supply this one out. If this one is with another solid now and you apply the techniques, the sublimation techniques, this one would actually disappear, leaving the other solid in the mixture. You get? So that's about that. Then decantation. Decantation is actually going to be using the principle of two distinct layers. How do I mean by layers? Decantation is actually employed in a mixture containing your solid and liquid respectively. Let's say this is our beaker now. This is our beaker that we use, and inside this beaker you now have solid particles. Alright, solid particles and your water, your normal water. So thereby forming two distinct layers. Maybe let's call this our layer 1, then this will be our layer 2. As you can see, it's in two distinct layers. So if you want to separate this, you can easily decant. What do we now mean by decant? So decant here is just you, like this one here, you just like collect this upper liquid. Are you with me? This upper liquid into another beaker. You simply collect it into another beaker, meaning that you now be left with only the clear liquid here, then you be left with this only here, this solid only here. So you just simply like you collect to another beaker. So that's you actually decant like that. That's decantation. So this one is actually employed in a solution, no, not solution, a mixture containing a liquid and a solid. For example, now if you have sand inside water and you need to, maybe you are very thirsty, or you have been very thirsty, you are dehydrated already, and you want to drink water, and you find out that this water is actually having sand particles in it. What will you do? You actually use for that water to actually it's not ideal, it's not okay. But since there is no water and you have to at least take something in so that you can be hydrated. So now all you do is that water that you see that is having sand particles, you wait for it to like settle on standing, like it will settle on standing into how many layers? 1 and 2 layers. Then you quickly tap off the water, you decant off the clear liquid that is up, because when it's in 2 layers, you have your clear liquid up because it's light, it's denser than this thing. Then you now have those ones that are dense, that are heavier dense. You have them like at the downward layer. So you now just decant off the up one, the one up, which is your clear liquid. Are you with me? So, and this is actually telling you that this place is very dense, while this place is less dense. So that's why this one come down, because it's heavily dense than water, so it has to come down. Show you. Are you with me? So this one, don't, the one up is now lightly dense. Are you with me? So let's go to filtration. Filtration. Now filtration is actually going to be like working on the principle of a porous, material. When you have a porous material, yeah, this porous material is something like a filter paper that can actually separate your insoluble, particles from a liquid. Are you with me? Let's take an example. Maybe you have a beaker now that is now containing a solid in a liquid. Are you with me? Solid in a liquid. What do you do? How will you and this solid is like insoluble. Like this solid now is insoluble. How are you actually going to separate this? So you simply filter. Since you say that the solid is not dissolving, so as you can clearly see the solid is actually not like dissolving. So you just go and get your porous material, which is your filter paper. Let's call this our filter paper. So you now put it in, maybe in a beaker. Alright. Let's put it in a beaker again. Alright. So you now pour this. You pour this into this filter paper, and what we would see is that the insoluble particles would stay on this filter paper, while the filtrate, which is the liquid, would enter the beaker. So this would be our clear liquid. Then this one will now be the insoluble solid, those solid that does not dissolve. So we'll now call this our residue. Please take notes. We call this our residue in chemistry. You don't just call it anyhow. Then you call this liquid that is being filtered of filtrates. Are you with me? So that's that. So separating, if you want to separate solid that does not dissolve, insoluble solid, from a liquid, you come and what? Employ filtration. And in chemistry, we use this filtration very well in water purification plants and brewing industry. So if you get to water, you would understand water solution and all. You understand this filtration well, because you see how the water would actually pass through various filter beds, and those insoluble particles or any particles at all will be left behind, on this filter bed. Then after that, after the water is being filtered, they will treat it with various chemicals to kill any bacteria or any germs before it's being piped to various homes. So filtration is employed in water purification plants as well as brewing industries. So that's filtration. So in our normal daily lives, for example, if you have a suspension of chalk in water, or let's say that of, how will I call it, maybe that of I'm trying to look for another example that we can use, or your granules in water. As you can see, these two things would actually not dissolve in water, so we can simply use our filter paper to filter out the insoluble solid, and we call that insoluble solid residue after we filtered it. Then the filtrate, liquid in the beaker that we collected as a result of filtration, will be called the filtrates. All right. Now, flotation is just like this one is actually talking about separating, when you have two insoluble but solid in a liquid. Yeah, so one is actually going to float, one will come up, the one that is not dense, the one that is lightly dense would come up, while the one that is heavily dense will go down. That's why you see this decantation 1, 2, 3 and 4 is working on the same what principle, is working on the same principle, because this 1, 2, 3, 4 here are actually separating what insoluble what solid from a liquid. Are you with me? So as you can see, they are somewhat what similar. It's just that what this one will do is different from what this one will do. Are you with me? And what this one will do will be different from what this one. As you can see, in the case of filtration, the solid is not dissolving, and in the case of decantation, you can see that the solid is kind of smaller. Are you with me? It's kind of smaller, so you cannot just say you want to filter. So it might pass through the filter paper. It might pass through. So you can see now. So yeah, principle of flotation, like when you have two dense, solid particles, like your sawdust now. Yeah, your sawdust, and let's say you have your sawdust here plus what should we use again? Should we use what example can I put inside this beaker? Let's put sand. Let's put sand. So our sawdust and sand. So if you have the two of them mixing together, it will be kind of hard for you to separate. Then what will you do? Just simply add your water. If you add your water here, if you add your water H2O, so now you're having water plus sawdust plus sand. So you see that actually the solid that is heavily dense will do what? Will come down. Thereby you having two layers. Okay, layer 1 and layer 2. This will be your layer 1, this will be your layer 2. So this one that is heavily dense is the one that will come down to this layer 2. So this one is heavily dense. So it's actually settled down to go down. Then this one that is lightly dense will now come up. This one that is lightly dense will come up, which is your what? Your sawdust. You see it up. You get up. Are you with me? You see it up. So that's why you can actually see that the sawdust is actually floating. And if the sawdust is floating, you can simply decant it off. You can simply like collect it over the sand. Are you with me? So therefore you have been able to separate two solid from a liquid. Are you with me? So that's just flotation. Now centrifugation will be making use of centrifuge to spin test tubes, like like it's like you having, let's make use of, let's try to explain, let's make use of this place. All right, so you are like something like you are having a centrifuge. Let me just draw it like this, something like this. So now you are now having a test tube here. So if you are having a test tube here, you have to counterbalance this thing with another test tube here again. So you have another test tube here, then you have another test tube here. Counterbalance it again. You have another test tube here. Then you have another test tube here again. So are you with me? So this is test tube 1, test tube 2, test tube 3, test tube. So you have five test tube here. So what will happen is that you're actually going to, this machine would spin this test tube with great speed. Like it will spin it very fast. Spin it very very fast at what? At great speed. And when it spins this test tube at great speed, we would have, this test tube would actually, it will cause the solid, because the particles inside this test tube would actually like, you get like in this test tube, let's draw it out. This test tube actually having your solid, and liquid mixed. Are you with me? Solid and liquid mixed. So this centrifuge will spin it at very great speed, causing this heavier the heavier particles to come down. And which one is our heavier particles? Is our solid, and it's highly dense. It's highly dense, so it will cause it to come down. Like this heavier particles, which is your solid, it will come down. It will come down. While the clear liquid will be up, then you simply quickly apply this techniques, decantation. Use it to, you decant it out. You decant this liquid out. You can decant it into another test tube or anything you choose to use. As you can see, this machine causes spinning at great speed, thereby pushing down the highly dense particles to the bottom of the test tube. As you can see, solid will be down. So as you can see, it's in two layers also, layer 2, layer 1. So the one at layer 1 is a clear liquid, then you decant it off. Very easy. That's centrifugation. So this one is employed in our hospitals when you are trying to separate the blood from the plasma. So we make use of centrifugation. So the next on the list is evaporation. Actually, evaporation. So evaporation here is actually working on the principle of you have your solutes, then you have your solvents. So solvents will dissolve the solids to form a solution. Are you with me? Like you having your solutes here is your solid. Let's take example, salts and universal solvents. You know your universal solvents, right? So what I'm giving us your what salts solution. Are you with me? So now the method of you recovering your solutes, which is your salts, from your solution, is what is called evaporation. So you evaporate that solution to what? To dryness. Let me add it professionally. Evaporation to what? To dryness. So evaporation to dryness is a method, a separating separating method of recovering your solute from a solution. So when you have your solution now, you just evaporate it to dryness. When you evaporate it, the water present in this solution would actually disappear. It will turn to gas, while the solute present would be left behind. It will be left behind. So by so doing, we've collected our solute from the solution. And please take note. You should take note that here this method is actually employed only in salt that does not decompose on eating. So your salt that does not decompose on eating. So yeah, that's evaporation to dryness. Alright, so yeah, so that's what will bring us to our crystallization. So since here you're actually getting your solute from solution, like solution giving you your solution, from solution you're now obtaining your solute. So you get after the solvent has evaporated, so this one will go, so it will now remain this one. So you get, but if only this one, you can actually use this method only if that your solute is actually not decomposing on eating, like that salt, that solid, if it's not like decomposing, like if it will not decompose on eating. Shey you get, so that when you are eating, it will not now go and decompose. But if this type of, if it's the type that decompose on eating, that's when you now gonna employ your crystallization. Are you with me? Now gonna, so this one, crystallization is used to separate salt that decompose on heating. Are you with me? So that's when you are talking about examples of your copper sulfate, copper tetrasulfate, heptahydrate. Then no, sorry, not pentahydrate. Then copper 2 triisonitrate 5 trihydrate, and that of iron 2 tetrasulfate 6 heptahydrate. So it's a method used to obtain salt that does not what, that decompose easily on eating. Sorry, that decompose. So if the salt does not decompose, you employ evaporation. But if the salt decompose easily on eating, you go for your crystallization. Are you with me? Crystallization. So, and then you have examples of it like copper sulfate, alright, dots are penta. That's what's penta. If you go to organic chemistry and you are having your methane ethane, that's your methane ethane, MEPBPHHOND. You can see that this is my 1, 2, 3, 4, 5. You can see that penta is 5 here. So this is how me I know that okay, penta is 5. I quickly flash back to the mnemonic I do use under organic chemistry, which is my methane ethane, propane, butane, pentane, then hexane, heptane, octane, nonene, MEPBP, HHOND. So as you can see that this my P here is penta. So I know that CuSO4.5H, that's copper sulfate pentahydrate. Should do for copper sulfate trihydrate like that. Since you know that 3 tri is 3, so should know that. So alright, let's go to distillation. Yeah, distillation. What is distillation? Yeah, distillation is actually the type of techniques you would use to like separate a solvent from a solution, like actually obtaining a solvent, a pure what solvent from a solution, like from a solution you're getting your solvent, and this your solvent that you're getting is actually pure. So your pure water, it's actually employed in all these water distilleries. Sure, you get water distilleries, water purification plants. So where you use your live liquid condenser, where the water will pass through the condenser, then would have the pure form coming as our this thing. So that's distillation. Distillation to recover solvents from a solution. And here we'll be taking note of, we'll be using the difference in the boiling point. You get here we'll be employing our BP, our boiling point, under distillation. So alright, that's distillation. Then alright, let's go to precipitation. Yeah, this precipitation here is just like you having two solution mixed together. Yeah, two solution mixed together. Maybe you have a solution before. Yeah, this precipitation, maybe you have a solution before. Are you with me? You now mix it with another solution again. So yeah, we'll now be able to, like, from here we now have to, so it will now form another solution. For example, how do I mean? Our silver nitrate is a solution plus sodium chloride solution. So you see that to give another solution of silver chloride, are you with me, plus NaN3, are you with me? So here you have a solution actually, and this solution is solution is another solution will give you a solid. So that's, so like you have a solution of silver nitrate now. So you now go and add another solution to silver nitrate, another solution. So these two solutions actually forms a particular mixture. Now when it forms a mixture, it forms a solid. That solid is now silver chloride. So this solid, how are we going to like get the solid out of the solution? Would simply filter it off. So when you filter this off, like you filter it off using your filtration method, so you now be able to obtain this solid from the solution. So that's precipitation. And precipitation will be based on the principle of taking note of solubility, difference in their solubilities. Are you with me? Their solubilities. So then separating funnel, right? Separating funnel is used separating. This is a method you use to separate two mixable, liquid, two liquid that mix, to immiscible, immiscible liquid. Why fractional would be mixable? But I'm not saying nonsense. So sorry guys. So mixable liquid, then immiscible liquid. So the one that would separate the one that does not mix, please take notes, would be the separating funnel. So separating funnel is you like having, let's use this place. Come, let me clean the board. Okay, sorry. Alright, so okay, now you having something like, let me draw something for you so you can. So you're having something like this, a stand that is actually carrying a beaker. Then you now have your separating funnel. You have your tap. This will be your tap. Then you have your mixture here. So here you have, so this example is common in kerosene and water. Kerosene and water would never mix. Yeah, kerosene and water will separate into two distinct layers. This is your separating funnel. Your SF. Are you with me? Yes. Then you have your water. Let's use water. Water here. Let's use H2. Sorry. Water here. Then you have, let's use petrol here. So you see that when you mix petrol and water together, it will never mix. Water is polar, petrol is non-polar. So your water here, which is very dense, then you have your very dense, sorry, your less dense petrol. Yeah, let's just 0 is 0 and minus for this. So what will you do? Since they did not mix, you pour the two of them inside a separating funnel. And when you pour the two of them inside the separating funnel, you can see that they are separated into two distinct layers. So this is layer 1, this is layer 2. And you can see that layer 2 is actually very dense, while layer 1 is not dense. That's why, because it's very dense, it will go down. You get it, will go down. So since it's very dense, it will go down. The one that is lightly dense will go up. So what will you do? You just open this tap, then you tap the water off. Like, you now tap the water, you see water will come. When you open the tap, water now enter into this beaker. So you'll be able to collect the water. Then when the water is about to, like, when you see that petrol is about to come, now you close the tap back. So definitely you've been able to separate. Are you with me? You've been able to separate the mixture of petrol and water, because you can see they do not mix, so they can never mix. They can never mix to form any single liquid, because they are non-polar and polar solvents. You get? So they will form two distinct layers. Then the lower denser liquid layer will be tapped off. Are you with me? So then, yeah, let's go to, I think this will be due to the difference in their boiling point also. Yeah, so yeah, then distillation. Let's check for distillation, fractional distillation, how we can obtain our, so unlike your separating funnel that is actually like separating a mixable liquid, fractional distillation here will separate mixable liquid. Don't forget where we are actually coming from. We are coming from mixture, how we have constituents that can be separated by physical method. Then I set out an example of palm wine, how palm wine is a mixture, and we have many more examples of a mixture. Actually, your blood is a mixture. Are you with me? Please take note. Your blood is a mixture. So it's not a compound. Your blood is a mixture. You have your Coca-Cola is a mixture. Are you with me? Your hair is a mixture of gases. You have your nitrogen, your oxygen, your noble gases, carbon 2, 4 oxide, and all. So yeah. So we now look at that we found out that all these constituents that make up a particular mixture would actually retain their individual properties, And if they would like retain their individual properties, we can take advantage of their individual properties to now separate them from each other. Are you with me? That's why we now came to this sieving of the stuff, magnetic separation, sublimation, decantation, filtration, blah 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 blah. So yeah, that was just a quick recap. Alright, so in the last video I explained matter. Anything that has mass and occupies space, you should check it out. Yeah, our matter is actually built of three elementary particles: atom, molecule, and ions, and whole. So alright. Yeah, so this application of stuff that I've explained in this video is, yeah, how would I call it now? It's like the application would be used in sieving, like sieving in mining industries, filtration in water purification plants. Where's filtration? Yeah, this is filtration in brewing industries and water purification plants. Then um distillation in making gin, because you use that one in gin distilleries or water distilleries. So you'll be using maybe your gin. So those people that used to make gin, they used to make use of this distillation very well, and water to obtain pure water. So you make use of distillation also. Then fractional distillation, that one is employed in your petroleum industry. Should we call it petroleum industry? Because you know your crude oil now, so you want to obtain them, so you want eat them up in a fractionating column. Are you with me? I don't want this lecture video to be very long, so yeah, we need to move actually. Then you have your precipitation and all. So crystallization now, this is the very best method to obtain your water and drug. Yes, you get your water and drug. Sorry, sugar and drug. So in pharmacy, we use crystallization to obtain our drug. Sure, you get. Yeah. So, okay. This is surgical medic, and I'm rooting for you. And this is surgical medic on your screen, and we're actually organizing a 7 days, 7 days free JAMB masterclass. So if you'd like to be part of this, you'd be part of this wonderful session, ensure you reach me on WhatsApp, or you click the link that is, I think is in the description. Yeah, it's in the description of this video. Yeah, you can click the link actually. Yeah, you can click the link. It's there. Alright, so feel free to reach me on WhatsApp. That is my number there. Just DM me. Okay, I want to join the free JAMB masterclass. It's actually going to be a Telegram. It's going to hold on Telegram because we are Telegram based, Telegram inclined. Alright, so then, and WhatsApp, the WhatsApp platform is for updates. Alright, updates. So we have our drills, yeah, on Telegram. See you there.